All right, good evening, everyone. This is National Weather Service, Des Moines, or this is where we're broadcasting from. I see we do have some attendees still just slowly rolling on, so we will give it another minute or two, and then we'll get started with everything. So once again, thank you for joining us, and we'll get started in just a minute. And as we see people still slowly trickling on here, just one or two quick items is this will be recorded. Right now, you are likely seeing 4 webcams at the top of your screen or somewhere on the screen there. The recording will not have the webcams, but we will have all the audio as well as the slides. So if you don't catch all of this, have to leave for some reason, or want to share this with other people down the road, it will be recorded just without the actual webcams on them. All right, so I think in the interest of time, we will go ahead and get started here. Again, I just want to say good evening to everyone out there, especially those of you that are in Iowa and anyone from outside the state that's joining us this evening. I'm broadcasting from the National Weather Service here in Des Moines, and I'm being accompanied by some, I guess in my opinion, some pretty fantastic individuals across the state that deal with climate. But before we go into that, again, just want to thank you for joining us. This is webinar number 2 in our kind of newly coined Weather Classroom series. If you joined us for the first one, I want to thank you for joining us for number 2. If you did not catch the first one, we did an office tour that kind of very loosely went into how we create a forecast and how warnings are created. So if you have any interest in that, be sure to visit our new education page. Can easily be found on our page at weather.gov/Des Moines/education, or if you just go to weather.gov/Des Moines, you can find the education page from there. All right, so kind of pushing forward to tonight, obviously the topic tonight is going to take us in a pretty different direction than the first one. So tonight it's going to be about climate. And like I said, we have 3 exceptional individuals that specialize in climate and are all based in Iowa. So they heavily deal with Iowa as well as, kind of the greater region. So one loose thing with climate in general, a lot of people out there I know tend to bin it into kind of a very historical climate record sort of aspect, or even on the other extreme kind of climate change. One thing we hope you take away from all of this is climate is much more than those 2 topics. Climate kind of delves into numerous aspects of our lives, many of which I don't think we always realize. So as we go through tonight, we're going to kind of be exposed to different aspects on how climate interacts with things like agriculture, short and medium range outlooks, climate change a little bit in there, and kind of the historical record of it. So again, a number of topics we're going to touch on that hopefully kind of broaden your horizons. So, but before we get into it, we also want to let you know there's just a little bit of housekeeping before we get started. So for the best kind of listenability for everyone out there, everyone is going to be muted except for myself as well as our speakers. So for you to ask questions, if you have the GoToWebinar software pulled up, you should see a little, typically it's on the right side of your screen, little status bar, and there's a questions section. Feel free to type any questions you have in there, and if we're able to get to them, we will. And some of that will be time dependent. So unfortunately, we may not be able to get to all questions, but we will do our best. And again, myself, I'll kind of pass the questions on to them. I'll be moderating this evening. And again, hopefully we have a good one. But I guess speaking of which, I should probably introduce myself. My name is Alan Curtis. I am a meteorologist with the National Weather Service in Des Moines. And actually, before I entered the National Weather Service, I was an assistant and service climatologist for the Midwestern Regional Climate Center. So I've had, in my opinion, I've been fortunate enough to know these 3 individuals for a number of years, though I'm not sure they feel the same towards me. So hopefully they don't chime in on that one. But like I said, it's been fortunate to know them all for a number of years here. But all right, let's go ahead and get into it. So before we dive into their specific topics, as well as some of the slides they have for us, I would like them to briefly introduce themselves to you tonight. And as we do that, I want to let you know we have Dr. Justin Gleason. He's, at least on my screen, the far right camera here, if you want to wave real quick so they know who you are. All right, very good. And then next we have Dr. Dennis Toddy. He's in the blue shirt there. And then lastly, and certainly not least, is Ray Wolf. And again, I don't want to steal their thunder, so I'm going to let them introduce themselves, kind of let you guys know what their job is, who they work for, and maybe some of the work you guys do within the state of Iowa. So we'll go ahead and start with Justin, if you'd like to take it away.
Thanks, Alan. And I want to thank the National Weather Service for facilitating this. This is a great group of individuals, and we collaborate and we work closely together for the state and for the region. So it's great to be with all of you and with the audience. I'm Dr. Justin Gleason, a state climatologist of Iowa, and I have been on the job for almost 2 years next week. And I'm originally from St. Louis, have 2 degrees in meteorology and a PhD in atmospheric sciences and climatology. So yes, I work for the Iowa Department of Agriculture and Land Stewardship in Des Moines. And my work is heavily oriented towards agriculture and our agricultural stakeholders, since that is what our economy is based on. I think of myself as the weather archivist for the state, the weather historian for the state. I have all the observations going back 148 years. So we use those to determine trends and where we've been, where we are, and where we're going. And that gives us a kind of a history of weather and agriculture across the state.
Awesome. Thank you, Justin. Let's go ahead and move to Dennis. Introduce yourself.
Yeah, I knew Alan back when he was just a student. So I'm Dr. Dennis Toddy. I'm the director of the USDA Midwest Climate Hub, housed in the National Laboratory for Agriculture and the Environment in Ames. We're housed on campus at Iowa State. Our responsibilities are regional in that we deal with climate and climate change and agriculture issues across most of the Corn Belt officially, and then we do bleed over into the Plains states a little bit because the Corn Belt extends out in that area, dealing with the wide-ranging issues of climate and agriculture near term and longer term. Originally an Iowan, 2 of my degrees from Iowa State. And my role is with USDA, but I have a pseudo role with Iowa State Extension because of the recent retirement of the extension climatologist. I've been helping fill in there, working, kind of splitting time with Justin, helping serve extension that way. So we help deal with near-term issues, but largely deal with, again, what's happening in agriculture, drought, wetness, whatever. And I was the state climatologist of South Dakota for 13 years, so I tend to think of things like Justin does, though I have to do it on a regional basis now.
Thank you, Dennis. And Ray, how about you introduce yourself?
Hi, I'm Ray Wolf. I'm with the National Weather Service office in the Quad Cities, and we cover the east central and southeast parts of the state, do the same thing for that part of the state that that Des Moines does for central Iowa. My role in the office, my title is Science and Operations Officer, so I'm kind of the technology and science transfer person, sort of like the extension person for the local office to help infuse the latest science and technology toward improving forecasts and warnings. I also wear another hat and support the Weather Service's Central Region Climate Program. That region goes from about Colorado to Michigan. And we, through that program, work with partners like Dennis and Justin and state climatologists from other states, with the National Drought Mitigation Center, through the NIDIS drought folks, so a host of partners we work with.
Very good. Thank you, guys. And just one more time, I see we had some more people trickle on. On the screen you're seeing there, if you do have any questions, we're keeping everyone muted other than the presenters. If you do have questions, you should see a questions area similar to what you see on the screen as an example there. So again, feel free to fire away questions. It could be as simple as, we like to throw out acronyms in a lot of our jobs, and we take them for granted. So if you see us doing that, don't be afraid to throw that question in there, and we will happily explain what it is. But again, I think for the most part, any and all questions are fair game. And again, if we can get to them and answer them appropriately, we will absolutely do so. But I think other than that, I don't see anything else that we need to touch on before we get started. So if Justin is ready, he's going to take it away first, and away you go.
Right, thank you, Alan. All right, so as I said, I view myself as the weather historian for the state. Again, we have 148 years of records for the state of Iowa, going back to our forts. What I'm going to show you now are the temperature and precipitation trends across the state going back to 1895. This is when we effectively, the federal record starts, and our weather observations are housed at the National Center for Environmental Information. This first plot here, and these plots will be similar, so we'll do since 1895, and then we'll show you the last 30 years, and we'll try to, we'll look and compare to what we've seen historically versus what we've seen in the short term last 30 years. So this first plot here is the statewide average temperature annually, going back to 1895, as I said. The purple line is the annual temperature for that year. The higher the peak, the warmer the year, the lower the trough, the colder the year. Now you can see lots of peaks and troughs there, lots of variability, but we have that blue line, and that blue line is the trend that we've seen decadally since 1895. So every 10 years. What we've seen in the temperature record is a 1/10 of a degree Fahrenheit increase per decade, going back to 1895. So where we are about 125 years since then, it's about 1.2 degrees above where we were. So a 1.2 degrees warmer than average. And if we go to the next slide, we have a physical relationship called the Clausius-Clapeyron equation. Now, what that tells us is that for any increase or decrease in temperature, you have to have an increase or decrease in the amount of water vapor holding capacity. So if we think of the increase that we've seen across the state of Iowa, and this is pretty relevant across the Midwest in general and the mid-latitudes, an increase of about 1 degree Fahrenheit in temperature gives us about a 4% increase in the amount of water vapor that's held in the atmosphere. More water vapor in the atmosphere, we're more inclined to have more precipitation events. So this next plot we're seeing is the annual average precipitation across the state of Iowa. Again, the higher the peak there, the wetter the year, the lower the trough, the drier the year. Lots of peaks and valleys there, but as you can see, that blue line is trending upward. And with that blue line trending upward, given our temperature increase, we've had an increase in the amount of precipitation that's falling across the state. So decadally, what we've seen since 1895 is about 4.46 inches of precipitation per decade, so about a ½ an inch increase as we have been moving forward. And this is a function of our temperature increases across the state. And we can go to the next slide. So first thing we'll look at here, this is a different way of viewing the temperature increase that we've seen since 1895. This is the observed temperature change across the United States in degrees Fahrenheit. Wherever you see red there, and the darker the red that you see, that's where we've seen a greater increase in the temperature. Across the upper Midwest, Alaska is where we've seen the highest increase in temperature, and this has to do with what's called Arctic amplification, but we can get into that now. But generally, as you can see across the United States, we're warming up, and it's greater temperature increases in the across the upper Minnesota, Wisconsin, Michigan. But then you look at the bar chart for the Midwest. This is per decade. Wherever you see a blue bar, that's where we've seen a temperature decrease for that decade. Well, as you can see, since the 50s and 60s, we've had an increase in the temperature across the Midwest, anywhere again from 1 to 1.5 degrees. And as I said, for the state of Iowa, 1.2 degrees Fahrenheit. And we can go to the next slide. Now again, by proxy, because we've had an increase in the atmospheric temperature, more water vapor in the atmosphere, we have a higher propensity to have more precipitation events. And what this plot is telling us in percent change is the greener the green you see there, the more percent increase that we've had in precipitation since 1895. So we do see a concentration of up to 10 to 15% increase in precipitation across the upper Midwest, the Dakotas, Minnesota, even over Iowa. Now you'll ask, well, you know, you're the state climatologist of Iowa, why do we care about rainfall and precipitation north of us? Well, all of that rainfall, all of that snow melt comes down in the Missouri Basin and the Mississippi Basin. We're in a unique setting here in which our eastern and western boundaries are major rivers, the Missouri and Mississippi. So with more precipitation, as we've seen an increase in precipitation, we're more inclined to have more flooding events, both flash flood events, but also aerial flooding, as we saw in 2008, 2011, and just recently in 2019. So we are seeing more floods more often, and this is tied into the precipitation behavior that we've seen. So we can go to the next slide. What we're going to look at over the next two plots is the same as the first two, but just over the last 30 years. So again, since about 1989, this is the annual average temperature for the state of Iowa, where we had a 1/10 of a degree increase since 1895 per decade. Over the last 30 years, we've actually seen a 3/10 of a degree Fahrenheit increase. So we've almost tripled, we've effectively tripled the atmospheric temperature over the last 30 years. And as you can see, because of that trend, the peaks are higher than the troughs are lower. So we've seen wetter years over the last 30 years. Now, if we look at 93, of course, that's the wettest year that we had across the state of Iowa, anywhere from about 48 inches of precipitation during that year, the Great Flood year. 2018 happened to be the second wettest year with 45.08 inches. So we've had a really wet stretch of weather over the last few years. If we go to the next slide. Again, because of our physical relationship with temperature and water vapor, with an increased temperature in the atmosphere, we've had an increase in the amount of precipitation that's fallen across the state. So anywhere, when we look at the statewide average, we're about 1.78 inches per decade over the last 30 years of precipitation increase. So yes, this is a very tied in perspective that we're seeing, because temperature and precipitation do go hand in hand. If we want to go to the next slide. So again, I do look at myself as a weather historian, a weather archivist for the state. So we need to look at where we've been. If we look at 2019, temperature-wise, we've seen the trends since 1895 and over the last 30 years. Now we can look at the short term that we've seen over the months of 2019. What you're seeing here are departure from normal temperature. So the lower that blue bar, the colder the month, the higher the red bar, the warmer the month. As you can see, we've had more blue bars than we've had red bars. For 2019, the statewide average temperature was 46.8 degrees, and that was about 1.2 degrees below average. In the historical ranking for the state, 148 years, it's the 29th coldest year on record. And a colder year last occurred in 2014. Now, if we look at some behavior that we saw across the state, September was the 9th warmest and October was the 13th coldest. And those are the kind of interesting things that climatologists and atmospheric scientists analyze. If we look back at 2018, April was actually the coldest April on record, and then we flipped to the 3rd warmest May on record. So we've seen these kind of weird two-faced changes really fast within the months across the state, and that's what makes our job interesting. Now, if we go to the next slide. This is the statewide average temperature graphically. So this is the spatial variation in temperature. Wherever you see darker greens, that's where temperatures were colder than average. But typically across the state, near average to about 2 or 3 degrees, or about 2 degrees below average. So that's where we get that 1.2 degrees below average. If we go to the next slide. The last two slides here is precipitation. So this is 2019 monthly precipitation for the state. The higher the blue bars, the wetter the month, the lower the red bars, the drier the month. For the state, precipitation averaged about 41.6 inches, and that's about 6.3 inches above average, which makes 2019 the 12th wettest year on record. Now, a wetter year, as I mentioned, last occurred in 2018, which was the second wettest year on record. Some highlights here: February was the 7th wettest, May was the 5th wettest. The meteorological spring months, March, April, May, were the 6th wettest, September 14th wettest, October 8th wettest, fall 7th wettest. So a lot of wet there. If you combine 2018 and 2019, historically, those 2 calendar years together were the wettest 2 years on record for the state of Iowa. So we've had some pretty remarkable wetness across the state. If we want to go to the next slide. This plot shows the county level amount of precipitation above or below average. So wherever you see red on that map is where we had below average precipitation. No red on that map, we were wet across the state of Iowa, especially along the Minnesota-Iowa border, and then along the Iowa-Wisconsin border. Historically, going back 2 years in 2018, there were 27 counties across northern Iowa that broke their precipitation records annually in November. Add on top of that, we were 3/4 of an inch above average in December 2018. We had an extremely wet stretch moving into 2019, and we still see those surface moisture, other features that we got from extremely wet conditions still in the ball game right now. And part of this is we get into talking about drought and abnormal dryness. Dennis will talk about this, but we've kind of staved off some drought.
Hey, Justin,
go ahead.
Can we go back for just a second? Was this plot for 2019 only?
This is 2019, yeah.
Okay, yep.
Yes. And if you look back at 2018 for this plot, the only county that would be red on this would be Davis County down in southeast Iowa, where we had D3 drought. Yes, so this is the 2019 plot. If you want to go back to the final plot here, this plot on the left here is the accumulated precipitation above average, above the climatological average from 1981 to 2010. Wherever you see greens and blues, that's where we're above average. So across the state of Iowa over the last 2 years, wherever you see those darker or those lighter blues, anywhere from 30 to 36 inches of above average precipitation. So that's a very wet stretch across the northern part of the state. On the right-hand side here is the historical ranking for 2 consecutive calendar years together. As you can see, 2018, 2019 was the wettest, but then you look 2007, 2008, and down that list, you have a lot of 2000s in there. So we've had a lot of wet years in the last 20 to 30 years, and we're kind of seeing a shift in precipitation behavior across the state. And I think that covers my section of it, so I'll hand it off to Dennis.
Well, Justin, before we get to Dennis, there was 1 or 2 little things here, and I think they tie in really nicely with what you kind of highlighted here with a lot of above normal precipitation is kind of, you know, the takeaway we've gotten from a lot of this is, I guess in your opinion, and obviously none of us are hydrologists by training here, but with, you know, numerous years well above normal precipitation wise, especially off to our north, would you draw a conclusion or even dare to draw a conclusion that that would lead towards, you know, higher end or more frequent flooding on our main stem rivers, and even some of our, you know, smaller ones in the state like Raccoon and Des Moines, things like that?
Yeah, I mean, if you look at the data and the observations, they point to that outcome, that conclusion, that if you have more water vapor, if you have more precipitation events, what we're seeing is also a shift in extreme precipitation events, rainfall events like the Ankeny June 30th event, where you get anywhere from 5 to 8 inches over 3 hours. You get into flash flooding. But yes, if you see an increase in precipitation basin-wide across the Missouri and Mississippi, and then you combine that with that infrastructure that was built 80 to 90 years ago, that infrastructure was not built for where our observations are pointing. So yes, that's a very good thing to think about, especially with flooding becoming more prevalent.
All right, very good. No, that's awesome. And one thing just of note, just to the audience too, tying into that is, Justin mentions infrastructure. A lot of municipalities across the United States base things on what we call the 100-year rainfalls or the 100-year floods sort of deal. But, you know, as Justin points out, we move towards more and more precipitation or heavier precipitation events. That's a moving target. So again, those are kind of like things where climate ties into, things we're going to have to address as we move along.
There's
I think
another
Dennis had something.
Yeah, there's another point to think about here too, that Justin didn't talk as much about the seasonality of precipitation. Additional precipitation is not necessarily linear with increased flooding, because we're seeing more spring precipitation. And if you think about what our soils are typically in the spring, typically they're wet or sometimes frozen. So additional precipitation will run off more readily. So another inch or two of precipitation on average will actually exacerbate flooding more quickly. So it's not necessarily just more rainfall, it's more rainfall at different times of the year.
Right. And I think for people in Iowa, I think it's 2018, maybe we had record precipitation in December, which we don't often get a whole lot of precipitation in December in Iowa. But like Dennis says, on frozen ground, 1 or 2 inches of rainfall can mean bad things. So no, that's a great point.
Yeah, and just one more point. In December 2018, we were actually 5.1 degrees above average. So most of that precipitation fell as rain, which we already had the 3rd wettest fall on record. So yeah, we got into a situation in which we had that bomb cyclone event in March, historic flooding, but that's for another time.
Yep. So yep, I think we're ready. Dennis, if you're ready, we can move to you.
Okay. Justin did a great job setting the situation. That one other statistic I love throwing out about in Iowa, we had some counties in the northeast part of the state over the last 2 years that have had over 100 inches of precipitation in a 2-year period. That's crazy. That's crazy amounts of precipitation. So now we're going to talk a little bit about more current situations, and oddly enough, drought. You'd say, you know, given what Justin said, God, we've got all this water, but we are currently talking about some dryness issues. And we want to talk a little bit specifically about, Chad, can we go ahead and walk through the other slides and then come back to the drought monitor? Let's do it that way. Okay, let's recap a few things here real briefly. Where are we most recently? Last month we've had for April, the last full month of data we had is for April. And the slides that we have here are from the National Center for Environmental Information. The link is down below. You can go look at these yourself if you want to. And what these show is where precipitation ranked during the month of April, going from 1, which would be the lowest amount of precipitation ever in April, to 126. 1 down here on the left-hand side, 126 on the right-hand side for the wettest. So it's interesting to look at where we were this spring and put that in some context of what's gone on. And also affected the agricultural situation, which we'll talk about here in just a little bit. So April for Iowa was the 15th driest April on record. So we were quite dry. Some of our neighbors to the west, Colorado and Nebraska, were the 6th driest. So after all this precipitation we've had, we've kind of flipped back to the dry side this spring, whereas off to the east and to the southeast, we were much wetter overall. Let's go to the next slide. February through April, temperature-wise, we were actually fairly warm. From looking at the last 3 months now, and the color coding here goes the same way. If you're in the blue, you're record cold. If you're on the red side, you're record warm. So Florida here is with warm water in the Gulf of Mexico. They've been record warmth. We were on the warm side February through April. And that sounds kind of odd, but what it points out is that February and March were quite warm, and then April actually turned fairly cold. If you'll remember, we had a large freeze event, a large period of very cold temperatures back in the middle of April with dropping some snow around us. So turned very warm into very cold. Let's go ahead and go to the next slide. February through April precipitation, where we were. We showed you April precipitation up in the northern plains. Iowa to the northern plains, again, was on the dry side, whereas just to our east, they have had much wetter conditions. Tennessee was the wettest February through April on record, where the northern plains were the driest. What that has left us with then is kind of what we were seeing so far. We've been talking about starting from, from the last 2 years, all this wetness. We were again wet last fall, and we had grave concerns about more flooding this spring and more problems from the ag community being able to get work done in the spring. But we actually had this flip to very dry conditions that has allowed agricultural activity to happen. Flooding to our west was largely nondescript, and there's some minor flooding in a few spots that are fairly flood prone. Whereas to the east, we've still had some ongoing flooding, more recently with some heavier precipitation events, and some extremes in that situation. Okay, let's go ahead and go back to the drought monitor then. Thanks. Okay, now, I don't know how many of you are familiar with the U.S. Drought Monitor. This is a product that is now 20 years old, and its job is to assess on a week-by-week basis what the status of drought is across the country. It addresses it on a category. It's a little small, but it goes from yellow, which is considered D0, abnormally dry, technically not drought. It means dry. We're not having any impact with drought. The tan is D1, moderate drought, and then it goes to a little darker brown to severe drought. The red is D3, extreme, and then I don't think we have any D4 anywhere in the country right now, exceptional drought. Areas that are in white are considered drought-free. We don't have any drought issues. Now, just because you're dry doesn't mean you're having drought conditions. You might think, given the numbers that I showed you for the spring, given we were way on the dry side, well, we should be considering ourselves more in drought. But the problem has been, because we were so wet coming into this, the dryness so far has largely been beneficial. As I mentioned, it allowed ag activity, it reduced some flooding issues, and really soils were not drying out too much. The surfaces were drying out, but there's still moisture in the soils. It had reached a point over the last couple weeks where it had dried out enough, crops were in, starting to be awareness that there was dryness. So there was introduction of this D0 area from Nebraska through Iowa up into southeastern Wisconsin. Basically, D0 is a recognition that, hey, things are kind of dry, but it's not too much of a problem yet. So there are a number of, some people have asked, okay, on the U.S. Drought Monitor, how dry do you have to be able to consider in drought? Well, there's not one thing that goes into it. There are some sample categories that go along with each of the levels, and some percentiles that are kind of aligned with that. But things that go into it are precipitation at various time scales, short-term and longer-term precipitations. What is your soil moisture like? What is, what are the impacts of it? Have you been warm or cold? If you've been warm and windy and low humidity, then that evaporates a lot of water from the soil. If you've been, like we have been the last week, cool, cloudy, and not rainy, but moist, that doesn't add to drought conditions. So these and a lot of other factors go into that. We have, all of us in here are on a list, and just to give you a background of how this goes, this is done on a week-by-week basis by a Drought Monitor author. There's one person each week that has authorship, and it is their responsibility to redraw this in about a 48-hour period. So they rely a lot on partners around the country to contribute, and all three folks here are able to give commentary, and we talk on a week-by-week basis with stakeholders. We want to hear from you if you ever have drought issues, to be able to point those out to us, because that helps us assess things on the ground. But what happens is, the author each week takes a look at the status, takes a look at input from people, looks at the data, and then tries to draw week by week, and there's some give and take between the national author and the local entities about what they think the situation should be. The national author has final responsibility and final say. One other thing to take note of, it's released on the Thursday morning, so this one was released today. It's valid as of 8 a.m. Tuesday, though. The cutoff date is Tuesday morning. So if you have severe drought situation, but you have a 5-inch rain Tuesday morning at 9 o'clock, that doesn't count that week. That gets counted the next week. So that's kind of an important thing that you take into account. And sometimes if you're having rainfall near that Tuesday morning, you kind of got to wait and see what happens. You'll see that not too far away, western Kansas, Colorado, some very serious drought issues, and we're getting past their rainy time of the year. So this could be an ongoing problem out in that situation, out in that area. So far, we're pretty good around our area overall. Precipitation over the next few days will probably start to eat away at this. Okay, I think that covers all the slides that I have. Let's bop down through. Alan, were there any questions or comments that came up?
Yeah, I think there's a couple of good ones here that tie into it, and that one may even tie back to Justin a little bit. So let's start with, actually, you hit on kind of southeast Colorado, southwest Kansas there with kind of they're in pretty bad drought. One of the questions coming in here wants to know, how do you determine, or how is it determined something is a short-term or a long-term drought? So for example, again, looking in southwest Kansas, it's delineated as a short-term versus the long-term in kind of the Four Corners region.
Okay, on the right-hand side, under the drought impacts, short-term is typically less than 6 months. You've had situations for less than 6 months, and then longer term is beyond 6 months. So, you know, and some examples are short-term are more agriculture, grassland kinds of issues, and the longer term is more hydrology, ecological kinds of issues. That's kind of the definition between shorter term and longer term.
Okay, so they're trying to take away like it's the overall impacts from it. So again, like in Colorado, Kansas, it's more agriculture, shorter term impacts versus, like you said, more of like, you know, like water providing lakes or anything like that.
Yeah, but it's also, if you've been dry in a place for 9 months, they would consider that longer term drought, whatever the impacts are. If, you know, once you've gone on that long, then it kicks over to longer term.
All right, very fair. All right, cool. So then this one is kind of a two-parter. I think it ties into drought as well as back to some of the images Justin was showing. So obviously we have increased precipitation as kind of the norm across the US over time. So I'll start with the drought aspect of it. So on the drought aspect, we're getting more precipitation over time, but how you get that precipitation affect something like the Drought Monitor? So 10 inches of rain in 1 day versus 10 inches of rain over 2 weeks. Is that a factor within the Drought Monitor?
Sure it is. Sure it is. Yeah, I mean, the precipitation totals, no matter how they come, are included. But if you have a big rain event, but then don't have rain for 2 weeks afterwards, that begins to show up in your soil moisture calculations, other kinds of indices. So, and we all know 10 inches of rainfall in one event is not as effective as 10 inches of rainfall over a month. 10 inches of rainfall here over a month is still a wet month, but there's a big impact, and you can kind of see the difference between that too. The other thing you'll kind of see that's kind of funny is you'll be watching a comparison to normal over a period of time, and you can tell when a big event drops off, because you look like you've been wet for a while, and then all of a sudden, oh wow, we suddenly dried out. Well, turns out there was a 3 or 4 inch event that was in the totals that dropped out of the totals finally. So.
Yep. All right, and then part two of this, kind of broader scope. So this maybe comes back to Justin with it. So with the increase in precipitation we're seeing, is it attributed more to high rainfall events, extreme events, or is it just more precipitation events, period?
As Dennis pointed out, there is a seasonal aspect to this. So we have seen in the trends more rainfall, more snowfall early in spring, and then last week of September, early October, we're starting to see more rainfall, and we've seen this over the last few years. We've had delayed planting, delayed harvest. If you look at the frequency and the probability of having an event, for central Iowa, about 89% of the time when we do have rainfall events, it's that gentle 24-hour 1 inch or less rainfall. That's where we get the majority of our precipitation. Now, over the last 20 years, we've seen a shift in that probability towards more intense rainfall events. So we are seeing more intense rainfall events more often, and that's where we start to see you have a rain gauge in one farm, and then 5 miles away you have another rain gauge. The rain gauge to the west will get 5 inches. The rain gauge to the east will get nothing. So we're starting to see higher intensity events that are on a smaller scale, depending on where you are and in what season you are. But we're also looking at summertime. About the second week of July, we turn off the faucet and it doesn't come back on for 3 or 4 weeks for measurable rainfall. So yes, we're seeing changes in both the widespread lower frequency intensity events, but also seeing a shift towards more higher intensity events as well.
Okay, no, and I think that's good information, because I think just from, even just anecdotally from my perspective, and I would imagine a lot of the public is, we remember the extreme events. So it's very easy to think that it's all coming in the extreme events as opposed to, like you said, more frequent rainfall too.
Right.
One more, I think maybe drought sort of thing, and this again ties back into the drought monitor, with kind of the extreme higher end droughts kind of off to our southwest in the front range there. Do you foresee, or is it anticipated that that's going to spread, I guess more into Nebraska, Kansas, into the Midwest in general, or if you have insight into that?
I assume they're talking about this year.
Yes, correct. Yep.
Yeah. Oh, should we turn that over to Ray and make Ray answer this one? So the part of the problem down here is they've been fairly dry. I don't know how long, a pretty extended period of dryness going on down here. And part of our problem with Colorado, Kansas right now is climatologically, this is about their average peak precipitation. So if they haven't made up ground by this point, it's hard to make up much more ground after this. So that's the situation we're dealing with. We still have opportunities for you. They can still get the rainfall, but there are things about climate and times that just don't lead to that much in the way of changes. So I don't expect to see, there are concerns about Kansas, Nebraska, because we are on the edge. It looks like over this next week, maybe Ray will talk about, there is precipitation coming that will alleviate that, but there is some concerns. I don't know how far out we'll get this summer and how bad it will get at this point, but okay.
That's fair, absolutely. So I think before we get to Ray, I think there's got one more question here I want to pose to the group. And it's a little broader, so to speak. Again, we've talked a lot about increasing temperatures, increasing precipitation. We've kind of driven that point home. And I think this is a fair question. So we talk about that. Summer's getting warmer in this case, but why is August usually a dry month for the state? And again, I think any one of us on here can answer it, so I don't know who wants to tackle it. I'll pick on.
I can start.
I didn't do very well in dynamics, so Justin, you take that one.
Right. So we have, you have the warm season, you have the cold season, you have winter and summer, and then you have the shoulder seasons, spring and fall. Well, the atmosphere is there's an energy cascade, and this is getting into grad school stuff, so we don't have time for this, but we're shifting dynamics towards smaller scale convective systems into larger scale synoptic systems. And when you think of synoptic systems, think of like low pressure systems and high pressure systems. Low pressure systems give us our rainfall, they give us our weather. High pressures are generally stable and we have nice conditions. So we're shifting from, we're starting to shift from smaller scale smaller scale dynamics towards larger scale dynamics moving into fall. August happens to be right in the middle of that, and it's kind of a transition month. Now, that being said, we have seen recently Augusts have been, especially the tail end of 2018 was wet getting into September. So it's not black and white in terms of Augusts being dry, but if you look at the dynamics in the atmosphere, we are seeing a shift from the warm season towards the cold season.
Yep. Ray or Dennis, want to add to that at all, or?
Well, I think, Alan, another way to look at this is trend versus variability. And certainly the trend over the longer term, as Justin nicely showed, is upward, but also that variability is still there. And we saw that last summer was sort of the, I think the textbook case, at least in eastern Iowa here, on how you can have a really wet year, yet you turn really dry in August to the point of we actually had moderate drought along the Mississippi River here. And then we flip back to the wet in the fall. So that kind of variability is really, that's the consternation point for folks whose livelihoods, I think, depend on the reliable climate that many of us who, grew up in the 60s and 70s were used to having back in the day.
Yep, no, that's also very fair. And I'll just say something out to the public too, touching on the dynamics Justin talked about too. One thing, if anyone's out there interested in kind of exploring this a little bit, just, Google search jet stream placement, things like that, because that's ties into a lot of what Justin was hinting at too. The jet stream placement drives a lot of the dynamics on whether or not we're seeing, our spring, early summer scattered storms versus higher pressure dominating, keeping us on the drier side. So that might be one good way to kind of ease into it educationally if you'd like.
Well, yeah. One more issue on the variability side that I love throwing in. With all the rainfall we had last year, South Dakota set some record stream flows. Now, I ask people, when is that? Oh, March, April, May, whatever, because we typically think about big floods in the spring when you've got snow melt, bigger rainfalls, etc. South Dakota had record stream flows in September. Some peak record stream flows in southeast South Dakota in September. So that's that, again, issue of our reliable climate shifting and doing things that we're not used to, or things that we're not ready to be able to handle in many different ways.
All right, no, very good. I do see there's a few more questions, but I think we'll let Ray jump in with his here, and then we can come back to some of these because they're topics-wise. I think they fit into multiple sections. So, if Ray, if you're ready, you can take it away.
Right, thanks, Alan. Well, I'll say Dennis and Justin had the easy part talking about the past. Now we got to build from what they said and look into the future. And a couple of terms that you'll hear are subseasonal forecasts and seasonal forecast. Subseasonal is usually refers to about a weekly time frame, generally over the next 2 to 4 weeks, maybe the next month or two. And as you get out toward the 3-month time frame, you're looking more at a seasonal type terminology. So putting that aside, another thing, when we make these forecasts, we do them in a probabilistic format. And I know people really like to have that deterministic forecast so that they can make some hard decisions on that. But the reason we do that is because the skill at forecasting weather day to day pretty much falls off very quickly after about 7 to 10 days. And about the best we can do beyond that time frame is try to pick out trends from the climatological average and infer some of the impacts from those. So you'll see that forecasts are generally couched in terms of above normal, say, precipitation or temperatures, or below normal precipitation or temperatures, and the use of the term equal chances. So what we do is we take the climatological record and basically divide it into thirds. And if you fall in the middle third, that's your near normal. For temperature, if you're on the higher third, that's warmer than normal. And if you're in the lower third, that's below normal. So what we're strictly forecasting is the probability to fall in one of those 3 groups. And we see the green marker there is centered right on Des Moines in the center of the state. And this is for week 2, the 8 to 14 day outlook, kind of for the end of the month and the beginning of June. And what we see in the light shaded blue is a slight probability increase toward the cooler than normal side. But if we look out west, we see a whole lot of red and a deep red. So we see the higher probabilities for above normal temperatures. And in fact, there's some expectation of some pretty extreme heat for the Southwest. And what this temperature pattern infers is a large ridge, which is generally associated with fair, dry, and warmer weather over the western part of the US, and then a trough, which tends to be associated with toward the cooler and wetter weather in our part of the world. If we could go to the next slide, Alan. We'll take a look at precipitation here, and then I'll introduce the pie chart on the left. We see we're in the tan area, which indicates that the odds are tilted toward the drier than normal side. So for wrapping up ag operations, getting planting done, Dennis can speak more to that, but that should be some good news there. Now, if we look on the lower left, we see a pie chart there that's got three colors, a gray, a light green, and a tan color. And because we're trying to forecast which tendency we're headed toward, we see the odds of being below normal precipitation are 38%. So since we're doing probabilities, we know that has to add up to 100%. So what we see here, the odds for above normal precipitation are only 29%. So the idea is that whatever category you fall in, for example, being drier than normal, that increase in probability comes at the expense of the lower category that is above normal precipitation. And when I communicate these, what I usually like to do is merge the equal chance category with the whatever the predominant probability is, in this case below normal. So really, for the week 2 time frame, there's about a 7 out of 10 chance that we're going to have near or below normal precipitation, which is good. So we're shying, the odds are shying away from the wet side. You could go on to the next.
And Ray, if I can interrupt for just real quick, on the 8 to 14 day forecast, and I think this ties into to the month ones and seasonal too. But if you recall off the top of your head, I guess how accurate or reliable would you say they are?
It's funny. I first came into the Weather Service way back in 1985, and I worked at a Weather Service office that was devoted to focusing on agriculture. And one of the things I learned really quick is how much the farmers really liked a 6 to 10 day forecast. And boy, back in that day, it was marginally skillful. But as we look at how things have evolved over the decades now, these 8 to 14 day outlooks are generally pretty reliable. Especially we've seen the improvement in skill over those decades, and especially in the last 10 or 15 years ago, as we get a better understanding as to what factors drive the forecasts on the subseasonal and seasonal time scale. And I'll talk about that a little bit as I wrap up. So for the season, this is June, July, August, we see Des Moines there, and in fact, Iowa is right in the middle in the category that would be termed equal chances, where you see much of the rest of the US, especially out to the west and the East Coast, the odds are favoring above normal conditions. And another way to interpret this is when the climatologists look at putting together the outlook, they look at the various factors, and there are really 5 factors that go into these subseasonal and seasonal forecasts. The first is trend, and just as Justin indicated, our trend is becoming warmer and wetter, but that trend, the degree to which we're becoming warmer, wetter, varies over season. So that's one thing they factor in. They also consider what the status of the El Nino Southern Oscillation is. Are we going to be in El Nino or La Nina this summer, trending one way or the other, or neutral? There's also a feature called the Madden-Julian Oscillation, which is basically a cluster of convection that moves across the Indian and Pacific Ocean primarily. And believe it or not, weather in that part of the world can have impacts on what we see here in this part of the world at certain times. Not all the time, but it can at certain times. We also look at the Arctic oscillation and North Atlantic oscillation, but the MJO and the Arctic oscillation tend to be factors more in that subseasonal time frame, while a trend and El Nino or La Nina tend to be the factors more influential in the longer time frame. And of course, I left out the best for last, and that's natural variability. And that's just the randomness that occurs in the atmosphere at all time scales, even from a few seconds to a few minutes at the local time scale, all the way out to the seasonal time scale. So we consider both of those. So for the summer, we're not seeing any strong indication of temperature leaning toward colder or weather. But if we take a look at precipitation in the next slide, that's way more interesting. And we are seeing, with some degree of confidence inferred by the higher probabilities, a tendency toward wetter than normal. And I think there are two factors going into this. One is the trend for our summers is tending to be wetter overall. The other thing is, and I'll show in a graph next, the expectation is for neutral El Nino status or neutral ENSO status, but there is a hint that we could move into the La Nina category. And what this complicated chart here shows, if you look on the left on the vertical axis, that's your probability. And you see the three bars there, the gray, the red, and the blue. The gray bar is for ENSO neutral. So we see that that's the most likely probability. And we see El Nino in red and La Nina in blue. And on the bottom axis here, like this JJA, that's June, July, August. So that's our summer forecast right there. So we see that for the summer, we're focused on ENSO neutral being the most likely outcome, and maybe a slight nod toward La Nina developing, especially as we look at JAS, which is July, August, September. We see a slight increase in the La Nina probability as we head into the autumn. So the forecasters have slightly tilted the outlook toward consideration that La Nina is at least a small possibility, while neutral is the most likely outcome. We see that at least going into the fall, La Nina comes in. So again, those 5 factors we look at for the subseasonal to seasonal time frame are trend, the El Nino La Nina status, the Madden-Julian oscillation, the Arctic oscillation and North Atlantic oscillation, and then natural variability. And of course, in our part of the world where the relationship of our weather to ENSO is not very strong compared to other parts of the US, the natural variability or sort of randomness tends to play a higher hand in our outlooks. And I think that might be a good point to stop and take any questions, Alan.
Yeah, no, that's perfect. And that's one thing there. I think you hit on it. If you didn't touch it, I was going to ask it. You know, why is Iowa often equal chances as we go into outlooks? But you kind of nailed it there for it. So there are some questions, and again, they're kind of a variety of topics. So we'll see what we can do here. First, and I think this maybe ties really well into Drought Monitor. Dennis hit on it a little bit earlier, but I think it can also play a role in what Ray and Justin do as well. But someone is asking, they say, you know, what can spotters do to help out? They're referring to, you know, traditional weather service spotters. But I think maybe more broadly, the public at large, what can they do to kind of help out things like the Drought Monitor, or Justin, like as you put together things for the state, or Ray, you know, our local weather service offices?
Justin, you want to take, oh, sorry, go ahead, Ray.
Well, I was going to say, for all three of us, the CocoRAS program, where you can sign up and buy a rain gauge, and it's a high quality but not expensive rain gauge, and you can report your rainfall amounts daily. And we actually, thanks for calling that up there, Alan. That data is invaluable. First off, it goes to the Midwestern Regional Climate Center and then to the National Center for Environmental Information in Asheville, and is archived permanently. We use it on a daily basis across Iowa for our river forecasts. We'll also, if we have big flash flood events, when we go back and do our post-event assessments, we'll use that to help understand what was going on. And on the flip side of flooding is the drought side. You know, 0 is a number 2, and you know, reporting a 0 precipitation is very important to know, you know, to confirm that nothing has happened. And when we get into drought mode, those data are extremely valuable. So if one is interested in being such a volunteer, I think the benefit to all 4 of us here on the panel through a broad range of programs, both real-time and historical, can't be undervalued. And the other neat thing is you have access to your own data too, in kind of a spreadsheet type format. So as you populate and collect the data over the years, you can actually go back and look at the data you collected years from now.
Yep. And very quickly, to that point, it's a great thing to do. And a very real life example is, and Justin, I might get a smile out of him with this, is Davis County, when they were experiencing a pretty extreme drought, you know, just over the last couple of years. There just weren't a lot of observations available in that part of the state. And one thing that was stressed to residents and people tied into agriculture there was to join CocoRAS, because without the information, things like the Drought Monitor couldn't appropriately reflect what was going on there. So again, without getting into the details, that's a very specific example where joining CocoRAS and submitting data, you know, paid dividends, had results. So I don't know if Dennis or Justin, if you have anything to add to that kind of topic, whether it be CocoRAS or just, again, ways the public can help you guys.
Yeah, I think CocoRAS is a good one. And Dennis and I had drought meetings down there in 2018, down in southeastern Iowa. And I think we added, since I've started, we've added about 170 new gauges. Not all are active, but when we do get into drought and we do get into wetness, those data that we collect with CocoRAS can be used to submit to FSA offices for CRP and crop indemnity insurance. So I use those observations from CocoRAS gauges, as well as National Weather Service co-op stations, for like I said, FSA and USDA insurance. And on the flip side of the wetness, also dryness, again, reporting zeros on the CocoRAS is just as important as reporting rainfall, but also drought impact reports. And Dennis can talk a little bit more about this. But if you're out on your farm and you see cracks in the field, you see your corn rolling, you see stream flows are very low or dry, take pictures of those, submit to the U.S. Drought Monitor or to me or to Dennis. And we use those on a weekly basis to craft our recommendation to the U.S. Drought Monitor. So those are the things that spotters can do that can help us outside of the severe weather realm. And spotters are very intuitive and they're very observationally oriented. So they are the group that can help us do these things.
And drought spotting is not as much fun as severe weather spotting, but it's a little easier to do.
Yes, yes, it is. Absolutely. It is just a little bit after 8 here, and I don't want to keep our panelists or people on too much longer, but we do have 1 or 2 more questions. Well, I can keep the panelists, I think, a little bit longer, but but those, if anyone does have to sign off here in the next minute or two, attendees, this is being recorded, so you can always catch up on the last few minutes. But again, we're going to do hopefully 1 or 2 more questions and then wrap it up. So there's one on here. Frost freeze related. So I think this is right up Dennis's alley, talking about how we had kind of the late season freeze after a relatively warm late winter, early spring. In a historical context, can you put into perspective how rare that really was? And is this something, where do you see frost dates moving in the future, if that makes sense?
Right, and we could do a half an hour, 45 minutes on this one. First, part of the problem that we saw with the April freeze was, one, it was very cold, but I tried to February and March being quite warm, so we had a lot of plants starting to break dormancy here and to our east and to our south, which is not a bad thing if you don't go below freezing. But that mid-April event was really not climatologically that odd. But it was, since we had a lot of things breaking dormancy already, we did some damage with that. The May freeze was climatologically quite late, and we set some record low temperatures along with that one. So that was a problem. But that is something we've started seeing a bit more with this tendency. Warmer winters, we're getting earlier dormancy break, especially some of our areas to our south and to our east, especially on perennials. And the freeze dates are gradually getting a little bit earlier on average, but there is high variability to that. So that we've seen this happen several times recently. We had, a couple this year. Back in 2017, we had some problems in the eastern part of our region. 2012, we had a freeze that did a lot of damage up in Michigan. 2007, I think there was a $4 billion event that hit the southeast U.S. with a late cold that did a lot of horticultural damage. So this is something that I want to caution people. The warmth kind of lures us in the spring, but we want to try to make sure we're taking care of what we're putting out there and protecting some of those things that are very or that are less frost resistant.
Very good. Justin, Ray, anything to add to that, to the frost freeze topic, or nope? All right. So we got, like I said, a couple more here. So there's kind of back to maybe dynamics a little bit. I'll still ask this one. We talked about, jet streams and kind of their placement just a little bit on how it can kind of drive our active or dry seasons. This is a little bit of a loaded question, but do temperatures themselves affect the jet stream?
Yes. So you look at the mid-latitudes where we live, in the high latitudes, the Arctic. The Arctic is warming twice as fast as the mid-latitudes, while the mid-latitudes are also warming. With a relaxed temperature gradient, that temperature gradient effectively drives the speed and location of the jet stream. So with a relaxed gradient, you're slowing the jet stream down. When you slow the jet stream down, it can back up on itself and you form these meanders, these dips. And those dips are what gave us the freeze events that we had just recently that Dennis talked about. But then you get on the flip side of that, you get temperatures that are above average or warmer. And one part of this is, we talk about the polar vortex. The Arctic intrusion back end of January, when we had temperatures down in the negative 30s, wind chills into negative 52, I think, Charles City. And then 4 days later, we have temperatures in the 50s and 60s, so a 70 to 90 degree swing. Long story short, you look at the relaxed temperature gradient, you start to see persistent patterns build in, and that's where we can get into dryness. But also, if the jet stream locks into a specific part of the United States like it did in spring 2018, you get really wet conditions along the Nebraska, Iowa, and Minnesota, Iowa border, and that's where we saw record wetness in 2018. So yes, temperature does control aspects of the dynamics of the jet streams.
Good. I think this can be open to anyone, this next one here. So this ties into, they're asking, is there a similar year to this year? Basically, is there a year in the past tracking similarly to 2020 as we stand currently? And then I'm going to add a part 2 to that. If there is one, or even if there isn't one, what's your opinion on using past years to try and predict what the rest of the year has for us?
Dennis?
I like analog years because they can help people identify. Okay, so there's a good in that. The reason I don't like analog years is where we go from this point is not predetermined. So if we're like X year, oh, here's what happened that year. Okay, we might end up like that, but there is a great possibility something different could happen. So it's not a guarantee. So analog years can help you kind of identify the situation and some of the impacts, but you have to be careful in thinking, oh, we know where we're going from here, when we don't always know that.
Right, and I think that's the great point, is that once you lock into an analog year, people take that as it's predetermined, this is what's going to happen, as Dennis said. And I think more often than not, you have to look at the probabilities on this. More often than not, it turns out differently. And that's where we can get into problems. I haven't looked at analog years for 2020. I think, did Doug mention something about the shift from ENSO neutral to La Nina within the growing season that has never happened before?
In the last 50 years, since 1950, only one time have we been in neutral conditions going into a growing season and went to La Nina during the year. I think it was 1971. Several times we've gone from El Nino to La Nina transitioning. Those have been some bad years there.
Well, and one thing I should have mentioned, Dennis, is that this time of year is about the worst time to make an ENSO forecast and be skillful. So the neat thing about climate is that the folks know when they have skill potentially in an outlook, and they know when they don't have skill. So and hence the reason for the use of probabilities. And trying to forecast what ENSO is going to be like the rest of the year from the spring is probably the biggest forecast challenge of the whole ENSO game.
Very good. So I mean, the takeaway from what you guys were just saying there is analog years can be used as a good thought exercise maybe, but certainly don't bet the mortgage that analog year is going to come true.
There's a statistical aspect to that. I'll say real quick. We do use analogs, and Alan knows, in the short term, like for days 1 to 7 and even week 2. Well, because if you go back and look at the database, we have a huge database of 1-day forecasts that we can do a statistical analysis from and associate what the weather pattern looked like to what sort of weather hazards occur. But when you look at it from an annual perspective, you don't have enough data points to really capture all the potential outcomes that you can have from what you've seen so far to date. And that's kind of a backwards way of saying what Justin and Dennis said, is that what we've seen so far this year doesn't predetermine what we're going to see the rest of the year.
Right, absolutely. I think there's one more question I'm going to pose to the group here, and then we'll wrap it up. So this one ties into, obviously we've had wet falls, 2018, 2019, so the last 2 falls that we've had. Is there any indication of, call it a root cause or cause, a pattern change, or any indication that this is becoming a new norm? Or would you maybe attribute it to, it's just the variability and we just happen to hit 2 wet falls in a row?
Well, if you look at, again, you don't want to, the more data points you have, the better the statistics that you can draw from the trends that you pull out of the modeling or the observations. So you can't say two wet falls, we're moving into wetter falls. Now, if you decompose or decouple the seasons from the annual trends, what we have seen recently over the past few decades are wetter springs and wetter falls. But again, Ray, when he talks about variability, variability is a key issue here. While you have an upward or a downward trend, you still have variability about that trend. So you always have to take that into account.
Yep, very fair, very, very fair. Yep. So it looks like, I think question-wise, we've tackled the majority of them there. There's one or two, I think one's tying into severe weather, storm season. Ask us offline for that. That's a little less climate, a little more, I guess, short-term weather. But with that, I just want to thank the people that are still on the line that listen to us to about 8:15 here. Thank you for attending. We certainly appreciate it. Look for some more of these going forward on different topics. You know, we hope to kind of keep the ball rolling on these various webinars. And I can't say thank you enough to our three panelists here that took about 2 hours out of their evening, you know, in terms of preparation and actually doing this webinar to help us out and really just to do this. So again, I want to say a sincere thank you to Dennis, Ray, and Justin. And again, to the people that are out there, we all live and work in the state of Iowa. So you're probably going to see us around in some form or another, whether it be interviews, social media. I think we all have social media accounts tied to work or personally. So, I mean, don't be strangers. If you have questions, I think I'm going to speak for everyone on here. We're more than happy to answer them if we can. And if we don't know the answer, we'll point you to where you can find an answer. So once again, I don't know if three of you, if you guys want to say any, you know, final parting words.
Well, thanks to you, Alan, for hosting this and getting us together. And thanks for the folks who attended for their time.
Absolutely, yeah. Thanks, Des Moines Weather Service Office, Chad, and especially Alan for moderating and getting us through this. It was seamless, and yeah, it was a great time. We're here as resources for the state and for the region. And again, to reiterate what Alan said, if we can't answer your question, we will find somebody who can. So please feel free to reach out to us.
And to the end, yeah, Alan, thanks for having us. And to our end, gee, you want us to talk about weather and climate issues? Gosh, yeah. When don't we want to do that?
Right.
But it is an example, too, of what we do in Iowa and around the Midwest, of federal and state partners sharing responsibilities, collaborating with each other. That makes it fun to be here.
Yeah, absolutely.
Yeah. Absolutely. So once again, thank you to everyone that attended. And again, thank you guys for participating with us. I'm sure it won't be the last time we do it. And again, with that, this is recorded. We will put it onto our website and other outlets going forward. So if you want to listen to it again, we encourage you to do so. So with that, we're going to go ahead and shut down the webinar and hope everyone has a wonderful evening. Thank you very much, everyone.